Hi everybody, welcome back to Dave's Math channel. I'm your host David Tare. This is my continuing feature on the Math Lovers book. And as I do every Saturday, I'm featuring another biography of a famous mathematician throughout history. These are featured in chronological order at the end of volume 2. I feature 80 altogether, and today I'm doing the 21st of those, and that's Simon de la Loubère. He was a French mathematician and diplomat and many other things. I think he worked for the king. And he lived from 1642 to 1729. And here's a picture of him in a very brief bio. He wasn't primarily a mathematician, but his mathematical claim to fame was that he came up with a method for constructing a magic square of any arbitrary odd order. The order has to be odd. It can't be even. This construction doesn't work for magic squares of even order, for instance, order 4, 6, or 8. For those, you have to do something a little more complicated. But at least for all the odd orders, like 3, 5, 7, and so on, his construction works. And it's actually a very simple construction. I'll show you how it works. Here's an example for a 5 by 5 magic square. What you do is you start with the number 1. People usually start this on the top row, the middle of the top row. You don't have to, but I guess the way he did it, that's how he did it. And then you go diagonally up and to the right, and you just count that way. So 1, and you have to wrap around if necessary. So you'll notice if you go past 1 on top, you get to 2 on the bottom, but the 2 on the bottom is actually wrapped around. So yeah, now it's on the bottom row, 4th column, and then you just go up to the right, and you can see the 3 is one row above and 1 column to the right, and then you wrap around again, you get a 4 in the middle left column and a 5 in the second column, second row and second column, and then you get back where you started, 1. And once you get back to where you started, you have to go to 6. And the way you do 6 is you zigzag. You don't go to where 1 is. You go to where 5 was. You zigzag down 1 square. And then you start a new set of 5. So 6 is, I think you can see the second row, third row, second column. Then you move up and to the right, get 7. Up in the right, get 8. Wrap around again. Get 9 lower right corner. I think you get the idea. And you have to do these diagonals a total of 5 times because there's a 5 by 5 square. And when you're done with a 5th of these diagonals, you'll have completed the magic square. And you could check for yourself that it's a magic square. In this case, all the rows, columns, and the main diagonal add up to 65. And you don't have to do it just for 5 by 5. It'll work for, like I said, any magic square of odd order. In this diagram, that would include 3 by 3, 5 by 5, and 7 by 7. 5 by 5 is just the one I showed you. 3 by 3 is known as the low shoe square. It's actually the unique magic square up to rotations and reflections of order 3. And then you have 7 by 7 on the middle bottom, and you can keep going like this. And I guess you can impress your friends because in general it's very hard to construct magic squares, especially in large order, but this very simple technique will allow you to do that. So anyway, that was Simon de la Loubère's mathematical claim to fame. And that completes my profile on Simon de la Loubère. So thank you for watching. Long live math, and I'll see you guys next time. Bye.